Hello and welcome to Mr. Wiley Teaches Math. Today we're going to be solving inequalities. Inequalities are not equal to's. We're used to working with the equal sign, which means equal to, but we're going to be working with these other five today. They're going to behave exactly the same way in an equation you'll see in a moment. We could actually pretend that they're an equal sign because they're going to work exactly the same, but they mean different things. If we see the equal sign with a slash through it, it means not equal to, greater than, less than, and then two new ones, greater than with a line underneath, which means greater than or equal to, and then the less than with a line underneath, half of an equal sign, means less than or equal to. So these five are going to behave in the same way as the equal sign, but they mean different things. So let's start by solving and then graphing. X plus 7 is greater than or equal to 11. And we're going to do this exactly the same way. I want to isolate the variable, have it on one side, and all the numbers on the other. Instead of an equal sign, it's my greater than or equal to symbol. So let's start by subtracting 7. X plus 7 subtract 7 is greater than or equal to 11. Subtract 7. X is greater than or equal to 4. For graphing, we're going to use a number line. So we're going to show x is greater than or equal to 4. Well, if I think of greater than, everything greater than 4 is 5, 6, 7, 8, 9, 10, and everything larger. And if I think x is equal to 4. So if I was going to graph it, I'd put dots on 4, 5, 6, 7, 8, 9, 10, as far up as my number line went. Solve in a graph again, but let's start with the variable t. T plus 7 is less than or equal to 8 plus 4. So let's just simply start by collecting like terms or answering 8 plus 4 as our first step. So we have t plus 7 is less than or equal to 12. We just collected like terms there. So now we want to isolate the variable, and let's do that by subtracting 7. Whatever's here we're going to undo. So t plus 7 subtract 7 is less than or equal to 12 subtract 7. And my variable t is less than or equal to 5. So again, if I think about less than 5, that would be all the numbers smaller than 5. And often number lines will stop at 0 when we're working with them in our textbook, but we're going to keep going just to show that it's all the negative numbers and so on, and all the positives, including 1, 2, 3, 4, and 5, because it said or equal to. So t is 5 or less. T is less than 5 or equal to 5. You can see that we did exactly the same thing that we would have done with an equal sign. You could almost pretend that, take those out and write equal signs down the side, and you can see that it's going to behave in the same way. The other four that we haven't talked about, if we were going to graph them, if we're going to show x is greater than 3, there's no or equal to, so I just have to think about greater than 3, so it would be 4, 5, 6, 7, 8, 9. But I would not include 3. Y is less than 2. Well, everything that's smaller than 2, 1, 0, negative 1, and all the negative numbers. But I would not include 2 because there's no or equal to. For x is not equal to 4, well, it could be any value except for 4. So I would choose every number that's on there, every number that's larger, except for 4, and every number that's smaller than 4. So x could be anything except for 4. If we ever had to graph, I don't know why we would, but if we had to graph x is equal to 1, that's just an absolute answer. There's only one answer. But for all the others, there's a possibility of answers, and that's what our graph is showing, that in each of these cases, our variable could be any of these. We're just not sure. These are our possible different answers. Thanks for watching. Be sure to check the class website for additional information in the assignments.